Hello, our names are DeIuliiSnell and Mackenzie DeIuliis. These are the final diagrams and gestural drawings of our project, Exhibit Des Moines. The site is located at 120 East 5th Street in the historic East Village of Des Moines. It sits adjacent to a formerly dilapidated but historically significant train depot and inactive rail line. As a part of our proposal, we are suggesting that the City of Des Moines follows through with their proposal to rehabilitate the rail line into a pedestrian bike path. This addition to our site would increase the public's exposure to these new technologies.
At the onset of this semester, we were tasked with researching 3 significant contemporary design robots, including their production process and their spatial requirements. Through this research, we became familiar with Maria Jablonita's Morphas robot, a string-weaving multi-species robot family. This diagrammatic exploration of her work was meant to be an analysis of body standards and their interactions with different robotic species. This diagram is accompanied by actual images of her work using Morphas. In their current form, Maria's robots move through their production spaces with the use of vacuum suction, magnets, track systems, and various other means of movement. They have been used primarily as a means of artistic intervention, resulting in experiential displays. We propose an exploration of this technique at a much larger scale of production. Our project will be best served by using the real climbing robot, but the operating surfaces that exist in our project could be adapted to facilitate any robot in the expanding family.
We hope to challenge the pedagogy of robots as purely a means of making art or robots as purely tools of industry and task them to functioning as both. Early on, we begin to consider the robotic production would be the focus of our facility rather than something hosted there. The robots act as a means of production, and we are framing the process of production as art.
The process of making on our site requires an overhead multi-axis robot, vertical grid structures with anchoring pegs, filament, resin, and wall-dwelling track system robots. The track system robots will inhabit the vertical grids, anchoring filament on the pre-existing pegs. Between each anchoring, the overhead multi-axis robot will unwind additional thread and taxi it over to the opposite grid, where it can be anchored. This process will continue until the form is complete and ready to be cast. We believe the process of iteration through to project completion could be outlined as follows. 1. Determine the desired form to be constructed. 2. Determine how the form needs to be woven. 3. Determine if a new or existing robot is needed for the task. 4. Fabricate the necessary robot. 5. Allow the robot to complete the woven structure. 6. Cast and cure a rigid piece using the woven form. 7. Cure the woven form. 8. Remove from the anchoring pegs. And 9. Transport to a final location.
As the brief stated, we were tasked with designing a facility that's approximately 30,000 square feet. As you can see, these spaces are shown with a breakdown of the square footage associated with each space in our building layout. In total, the facility is approximately 26,000 square feet. With the old rail line now becoming a pedestrian and bike path to benefit the local economy, our site relies on large trucks loaded at the southwest edge of the production facility to transport the exhibition pieces to their final destinations. The required program of our facility includes robotics labs, an education suite, an administration suite, a research suite, and public spaces. We chose to integrate much of the existing depot space as administrative facilities, as our primary robotic space is housed in an open-air glass building in which the weaving robots will be used for research and production. In between the robotic facility and the research center, we propose that an extension of the grid structure and weaving robots, which will provide space for additional testing as well as functioning as shading device.
In the portions of the building without the filament shading structures, fritted glass will be utilized. A steel structural system makes up the majority of this building. Certain areas are supplemented by exterior grids with the weaving robots acting as shading. Besides that, a glass curtain wall system will make up the majority of the facade. Aesthetically, the building remains simple enough to function as a true backdrop to the process of production. While our facility caters heavily to research and the people composing it, much of the site is and will remain the domain of robots. The building and program embody a process of gradation from human through to production. The facility rises slowly in height across the length of the site, the highest area being the robotic production space.
In this facility, we hope to create an in-between place, one that's focused on the intersection of the gradation of human robots and inhabitation. Robots inhabitants on the interior and exterior of the building lend themselves to interesting displays and offer shading during the process.
Within the production side of the site, the Morphos robot moves through the process of weaving, the benefit of this technique being the scale at which the forms can be cast.
The different scales and phases of weaving around the site lend themselves to constantly changing facade conditions. Each bay in the production facility, between the buildings and around the labs, function independently, which would allow for completely disparate stages of this process to be occurring simultaneously.
Thank you so much for your time. We look forward to hearing your comments.